Namaskar, welcome to the channel Anka Ananda Haran. That is, let us extract happiness from the teaching learning process of mathematics. Making of this video is intended to make all the students who are interested to do self-study from Gilbert-Strang book of Applied Linear Algebra. Here we will discuss some of the aspects that are being discussed in Gilbert-Strang book, and after knowing which a student will be able to do study independently using the same book. So here is an example from the book. It is being considered. Consider the system of equation. 2u plus v plus w is equal to 5. 4u minus 6v is equal to minus 2. Minus 2u plus 7v is equal to plus 2w is equal to 9. This system of equation is a non-homogeneous system of equation with three unknowns. Unknowns are u, v, w. RHS vector is consisting of three components, that is 5, minus 2, 9. And if the RHS vector, in this case which is non-zero, if the RHS vector is 0, the system of equation is a homogeneous system of equation. And for a homogeneous system of equation, 0 vector is always a solution. Now, we will solve this system of equation by Gaussian elimination method. The question is, what do we mean by elimination? Eliminating a variable means making its coefficient 0. Okay, so what we will do? Using the coefficient of u, v, w from first equation, we will make the coefficient of u from first and second equation to be 0. How to make it? If I multiply 2 with the first equation and subtract it from the second equation, my second equation's u will be having a 0 coefficient. Similarly, if I add third equation with the first equation and store the resultant in the third equation, then in my third equation also u will not be there because its coefficient will be 0. Okay, so now after these two operations, what is my augment matrix? Augment matrix is 2, 1, 1. Augment matrix means a matrix in which coefficient matrix is augmented with the RHS vector. So here minus 2, 7, 2. This is my augment matrix. Here, if I write what I am getting, what operation I am doing here on this matrix, what operation I am doing, here is something left. I am doing two operations. First operation is R2 minus 2R1 stored in R2. Then R3 plus R1 stored in R3. What I am getting after these two operations here, first row is not changing. Let me write as it is. Then my second row will be 4 minus 4, it is 0. Minus 6 minus 2, it is minus 8. 0 minus 2, it is minus 2. Minus 2 minus 10, it is minus 12. Similarly, adding these two, minus 2, it is 0. 7 plus 1, 8. 2 plus 1, 3. 9 plus 5, 14. So this is my new matrix. So here from the second and third equations, the coefficient of u is made 0. That is, u variable is eliminated. Now, from the third equation, I want to eliminate my v variable. So what operation I should do? Here, third equation R3 plus R2 stored in are 3. So here what I will get? The resultant is 2, 1, 1, 5. 0, minus 8, minus 2, minus 12. This is 0, 0, 1, 2. Now observe, from my third equation, my second variable is also eliminated. Only one variable left. From this one variable, I can find out the value of W. What is the equation here? Here, this is in echelon form. Here, this is a pivot, this is a pivot, and this is a pivot. Why it is said to be a pivot? If this variable is becoming 0, then I cannot find out the value of U. If this variable is becoming 0, then it will create a problem to find the value of V. Similarly, this variable, if it is 0, then it will be a problem to find out the value of W. Okay, so these are crucial values of the matrix. So they are pivot. So using these pivot elements, observe, using these 2, I have made here 0, here 0. Similarly, using this minus 8, I made here 0. So these are the pivot variables. Now, after getting this situation, I will write the equations in the reverse order. So first I will get my W value. So here forward elimination. First I eliminated U, then I eliminated V. Then I will go for the third variable. So elimination is forward elimination, but substitution, first I am getting W is equal to 2. Then minus 8 V minus W minus 2W is equal to minus 12. Here already W is equal to how much? Here W is already with me, which is 2. So it is going to that side, it is minus 8. So V is equal to 1. From here I got my V is equal to 1. So once I substitute my V and W equation, what is the first equation? 2U plus V plus W is equal to 5, which implies U is equal to 5 minus 1 minus 2 by 2, which is again 1. So what I got my solution? Solution is U V W is equal to 1 1 2. This is all about elimination method by Gauss. Let us study it systematically from the Gilbert-Strang book. All these things, whatever these cuttings are available here, everything is from Gilbert-Strang book. So one need not get confused. So what we will get? So here the first U variable eliminated, I got this equation. Then my V variable eliminated from the third equation, I got this. Here these 2 minus 8 and 1 are the pivots. The coefficient of U in the first equation and the coefficient of V in the second equation and the coefficient of W in the third equation of the triangular form are called the first, second, third pivots respectively. Here this pivots presence will give us unique solution. If all the set of pivots are there, then the system of equation will have unique solution, because W will have a unique value, V will have a unique value, and U will have a unique value. Okay, so next question is whether the same, if whatever we discussed in equation form, if in matrix form we want to do it, then we will get in this format which already we have discussed. So During the process of elimination, there may be a possibility of breakdown. There are two types of breakdown. One is temporary breakdown, another is permanent breakdown. If a 0 appears in a pivot position, elimination has to stop either temporarily or permanently. If the 0 pivot can be replaced by a non-zero value by row interchange or row exchange process, then the breakdown of elimination process is temporary or else it is permanent. Consider an example of a non-singular case. As the name indicates, it is non-singular. That means it has full set of pivots. So observe here in the first equation, first system of equation, what we have done? We have this system of equation u plus w plus u plus v plus w is equal to something. So here each variable is there. Now from the first equation, I want to eliminate, from the second equation, I want to eliminate my u variable. That means I want to make its coefficient 0. So what operation I will do? The coefficient in the coefficient matrix, what operation I will do? The coefficient matrix here is 1, 1, 1. It is 1, 1, 1, 2, 2, 5, 4, 6, 8. Now here my target is to make it 0. So what operation I should do? I should go for R2 minus 2R1 stored in R2. Already about this elimination process and elementary row operations, elementary matrices, already in the first two videos we have discussed. So I will not discuss much about how these operations are carried out, but I will apply them now. So here from this twice first row is subtracted. So that means here I got a 0, here I got a 0, here I got a 3. Similarly, to get here 0, first of all let me complete this process. So second operation, what operation I will do? To get here 0, that is coefficient of u in the third equation 0, what operation I have to do? It is 4R3 minus 4R1 stored in R3. Let us do that. How we will do? 4, this is 0, 4, 6 minus 4, it is 2, and 8 minus 4, it is 4. Coefficient matrix only we are discussing. Now one can observe that in the second position, first 1, 1 position, that is coefficient of u in the first equation, coefficient of v in the second equation, coefficient of w in the third equation, they are pivot. So in the second pivot position, I have a 0. That means my second pivot is missing. That means I cannot eliminate, my elimination process breaks down because the coefficient of a second pivot from the second equation is 0, using which I will make all other variables, all other values to eliminate. So here, as my second pivot is missing, my elimination process breaks down, but this breakdown is not permanent, as suppose I will interchange these two rows. What I am getting? R2 interchanged with R3. Then what I am getting? 1, 1, 1, 0, 2, 4, 0, 0, 3. Again I got my pivots existing, non-zero pivots. All the three pivots are non-zero. That means my system of equations elimination process breakdown was temporary. Now by interchanging row or doing row interchange, I am getting all these pivots, non-zero pivots. So it is temporary breakdown. So this is all about temporary breakdown. Now let us go for a permanent breakdown. So here the same thing is written in terms of equation format. but there we have done in terms of augment matrix and coefficient matrix format. Now here what will happen? In this equation, observe what happens. One, 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 2, 2, 5, 4, 4, 8. What operation I will do? To eliminate this 2 and this 4. These 2 I want to eliminate. So what operation I will do? R2 minus 2 R1 stored in R2. Similarly, it is similar to R3 minus 4 R1 stored in R3. So what I will get? 1, 1, 1, 0, 0, 3, 0, 0, 4. So here one can observe that the second pivot is again missing. But in this case, by row interchange of these two rows, I cannot make this 0 pivot as non-zero pivot. I cannot replace it by any non-zero value through row interchange. So this pivot is missing means my elimination process breaks down. And if I cannot replace it by a non-zero value through row interchange means the breakdown is permanent. So in this case, we have permanent breakdown. Okay, it is in terms of matrix format. If in terms of equation format we will write, so here it is as per the Gilbert-Rami book. So here the coefficient of V in the second equation is 0, which cannot be made by which cannot be made non-zero by any row interchange operation. Hence, the breakdown is permanent. So here we studied about temporary breakdown, meaning of temporary breakdown and permanent breakdown. Next question is, what do we mean by a singular system of equations? A system of linear equation is said to be singular if and only if the corresponding coefficient matrix is singular. A matrix is singular if its one row or column can be written as a linear combination of other rows or columns. Now one can clearly analyze that. The breakdown is temporary for a non-singular system of equation that is having full set of pivots, and the breakdown is permanent if the system of equation is singular. Now let us discuss some of the problems from the exercise. Here is a question. What RHS value will make this system of equation with no solution, and for what value it will have infinitely many solutions? So what is the coefficient augment matrix? 3, 2, 10, 6, 4, C. What operation I should do? I want to eliminate this. So what operation I should do? R2 minus 2R1 stored in R2. How much I will get? 3, 2, 10, 0, 0, C minus 20. Now, this system of equation is having once no solution when this is C minus 2 is non-zero. For C minus 20 is not equal to 0 implies no solution, and C minus 20 is equal to 0 or C is equal to 20 implies the system has infinitely many solutions. Okay, so this is all about this question. Next question of the second part of the question is, for Find a solution for x equal to 2. Now, what are two solutions of those two equations, of those solutions? So, when it is C is equal to 20, the system of equation, as it is a singular system of equation, observe here one of the pivot is missing. As one of the pivot is missing, it is singular. In this format also one can tell, or 3 by 6 is equal to 2 by 4, hence it is singular. And if it is equal to 10 by C, then the system of equation has infinitely many solutions. So it is also another way of evaluating. So in that case, C is equal to 20. So what are the solutions then? This equation will become, when C is equal to 20, this system of equation will have solution. How much? What's the equation? 3 equation variable xy. So 3x plus 2y is equal to 10. I got this equation. Here for every value of y, I will have a solution. So for every value of y, I will have a solution. Let us take y is equal to 1. Y is equal to 2. How much the solution is? Y is equal to 2 implies x is equal to 2. It is one of the solution, xy. How? Y is equal to 2 means it is 4. 4 can come to this side. It is 6. 2x is equal to 6. So x is equal to 2. 3x is equal to 6. Hence x is equal to 2. Next, let us substitute y is equal to 0. Then what will be the other solution? Y is equal to 0 means x is equal to 10 by 3. So my other solutions will be x and y is equal to 10 by 3. It is 10, it is 0. This is another solution. Likewise, we can find out for every different value of y, one solution. Let us discuss here. So here, every point on the straight line 3x plus 2y is equal to 10 is a solution. In particular, x equal to 2 implies y is equal to 2, x equal to 1 implies y is equal to 3.5 are the two solutions of this system of equation. Now, here it is asked, choose a coefficient b that makes this system of equation singular and choose a right hand side g that makes it solvable. Find two solutions in that singular case. It is as usual as the previous question. 2 by 4 is equal to b by 8 implies that is equal to 16 by g. So here b is equal to 4, g is equal to 32 gives us this system of equation has infinitely many solutions. In particular, this 2x plus 4y is equal to 16. Here, let us substitute x is equal to, so every point on this straight line is a solution. In particular, x equal to 2, y is equal to 3, x equal to 6, y is equal to 1 are two solutions of it. One can substitute and verify these are being satisfied. Similarly, let us consider this equation, another equation. Here also, the question is almost similar. So, what multiple L of equation 1 should be subtracted from equation 2 so that my x variable will be eliminated from the second equation? It is a very simple and common question, that is 2, 3, 1, 10, 9, 1. It is the augment matrix is this one. So how much should I multiply to the first equation? It is R2 minus 5 R1 stored in R2. That is 5 times of first equation should be subtracted from the second equation to eliminate my x variable. Now after elimination it is eliminated. It is 15 minus 15 9. So it is minus 6 and here it is 5 times. Minus 5 plus 1. So here 5 times minus 5 plus 1 minus 4. So this is a system of equations. So once this system of equations, it has how many pivots? This is a pivot and this is a pivot. The second part of the question contains this one. After elimination step, write down the upper triangular system and darken the two pivots. So here this is after elimination we got this triangular form, and here 2 and minus 6 are the pivots. Okay. Now question number 7. What test on B1 B2 decides where these two equations allow solutions? Whether these two equations allow a solution or not. How many equations will they have? Draw the column pictures. So first of all, and what is the column form notation? The given system of equation can be written as x into the column vector this 3 and 6, y into the column vector minus 2 minus 4 is equal to b1 b2 vector. Now here this system of equation is having solution. That means again it is a singular system. Here what happens? 3 by 6 is equal to minus 2 by minus 4. Now as the system of equations satisfy these two conditions, that means it implies that it is singular. Once it is singular, to have solution, the RHS vectors components should also satisfy the same condition. That is this relation. So here the B2 should be twice B1 to have a solution of this system of equation. So condition is B2 should be twice B1. Next, from the column picture, this is my V, this is my V1, this is my V2, this is my V3. One can observe in every case the system of equation are having, these components are related, that the x components twice is the y components. That means they are related by the same relation. So all of them will lie in one straight line. So this is the graph of the curve. Here if the point B1, B2 lie on the straight line, this is arbitrary point we have taken. If this B1, B2 point will lie on this straight line, means the relation B2 is equal to twice B1 satisfies, then the point will lie on the straight line. Then the system of equation has solution. Otherwise, in that case, this number of solutions will be infinitely many. Every point on the straight line is a solution. Otherwise, it has no solutions. So, next question is, for which number A does the elimination process breaks down permanently, for another for temporarily? Now here observe the coefficient matrix. What's the coefficient matrix? Here the coefficient matrix is A, 3, minus 3, 4, 6, 6. This is augment matrix. Now we are not interested about this augment part. Directly only coefficient matrix we will consider. Because breakdown temporary or permanent, that is being asked. So here, if this pivot is becoming 0, then there will be a breakdown. But in that case, the system of equation is non-singular. So the breakdown will be temporary. So if A is equal to 0, what happens here? A is equal to 0 means 0, 3, 4, 6. Now here, as my first pivot is missing, there is a breakdown of elimination process. But after a row interchange, R1 interchanged with R2, what I am getting? 4, 6, 0, 3. My both pivots are non-zero. So it has full set of pivots. Hence, the breakdown was temporary. But if my A is equal to 2, how to get it? From again the condition of the singularity, that is they are proportionate. A by 4 is equal to 3 by 6. In this case it will be singular. If it is singular, then the breakdown is permanent. How to do it? So that means A is equal to 2. This implies A is equal to 2. So 2, 3, 4, 6. After row operation, R1, R2 minus 2 R1 stored in R2. Stored in R2. It gives me 2, 3, 0, 0. Now here my second pivot is missing, but the missing pivot cannot be replaced by a non-zero pivot. Hence the breakdown is permanent. Next we will move to another question. That is question number. Which number q makes this system singular? And which right hand side t gives it infinitely many solutions? Find the solution that has z is equal to 1. Here, what is the system of equation? X plus 4y plus 2z is equal to 1. So this is my first equation. And similarly, x plus 7y minus 6z is equal to 6. Similarly, 3y plus qz is equal to t. This is my system of equation. Here, already the first variable is eliminated from the third equation. Only I have to eliminate this. The corresponding augmented matrix is this matrix, and here I have to eliminate this variable. So for which R2 minus R1 stored in R2, this operation will be sufficient. So after operation, what I am getting? I am getting 1, 4 minus 2, 1, 0, 3 minus 4, 5. This is 0, 3 minus 4, 5. And the third equation remains same. So now this 3 I want to eliminate. So what should I do? R3 minus R2 stored in R3. So that will give me this equation. Now observe here, the first and second rows are same. So third row, this variable became 0. And here 4 q minus of minus 4, that is q plus 4. And here t minus 5. So what does it indicate? It indicates that if q plus 4 is equal to 0, then t minus 5 should be 0. And if q plus 4 is equal to 0, then it is its third pivot is missing, hence the system is singular. Otherwise, other two pivots cannot be missing, already they are scalar constants. We have obtained the constant values and they are non-zero values. So only possibility to make it singular is to make the third pivot missing. If this third pivot, this pivot is missing, then only the system of equation will be singular. To have singular, that means this is 0. So it is 0 means q is equal to minus 4. So for q is equal to minus 4, and if it has solution, that means t minus 5 also should be equal to 0. So when q plus 4 is equal to 0, that is equal to t minus 5, that is t is equal to plus 5. Q is equal to minus 4, t is equal to plus 5, the system of equation has infinitely many solutions. In that case, this system of equation, this is 0, this is 0, it will change to this equation. Here, how to write down the equation? Here the equation can be written as, there is a line between them, that is 3y minus 4z is equal to 5. So here, for every value of z, there exists a solution, but given z is equal to 1. So when z is equal to 1, we have y is equal to 3. And from the first equation, x plus 4y minus 2z is equal to 1. Hence, x is equal to minus 9. So I got my y, I got my x, z is already given. So x is equal to minus 9, y is equal to 3 and z is equal to 1. This is a solution of the system of equation. With this we will stop this. So here the question is, if rows 1 and 2 are the same, how far can you get with elimination? Which pivot is missing? Observe here, this matrix can be written as, the corresponding augment matrix can be written in this format. So here, to eliminate this variable, what we have to do? R2 minus R1 is stored in R2. So then this whole row, as my first row is equal to second row, first equation equal to second equation, so whole second row is missing. So that means this pivot, second pivot is missing. As my second pivot is missing, I have a breakdown in the elimination process. But by interchange of second and third row, I will get my second missing pivot replaced by a non-zero value. So my first pivot is non-zero, second pivot is non-zero. Now I have my third pivot missing. In this case, the breakdown was temporary, and now as my third pivot is missing, which cannot be replaced by any non-zero value, so here the breakdown is permanent breakdown. So the second pivot is missing, hence elimination breaks down, and a row interchange gives a non-zero second pivot, but the third pivot is missing, hence the breakdown is permanent. Similarly, observe here in the same question, another set of equations are given. 2x plus 2y is equal plus z is equal to 0. So here what happens? The first and second columns are same. So the augment matrix of the system of equation is written like this. After having this elementary row operation, what we are getting? 4, they are having here 0, 0. And when I will go for this operation, I will have this also 0, 0. So now when my first variable is eliminated, I am observing my second pivot is missing. But that missing pivot cannot be replaced by a non-zero value. by any row interchange. Hence, the second pivot is missing and the breakdown is permanent. Today, we will stop our discussion here. In next video, we will discuss furthermore aspects of applied linear algebra. Thank you for your patient listening.